students, welcome to Alpha Mathematical Institute, Avadi, Chennai. In this video, we are going to discuss a problem on integral equations. Okay, so let us see the problem. If phi is the solution of integral 0 to x 1 minus x square plus t square into phi of t into dt equal to x square by 2, then phi of root 2 is equal to, okay. So actually here the problem is phi is the solution of this integral equation. We need to find out what is phi of root 2, right? So first let us calculate what is phi of x. Then we put x is equal to root 2, we will get phi of root 2. So before solving this problem, we need to know what is Leibniz rule. Let us write what is the Leibniz rule. D by dx of integral sum g of x to h of x f of x comma t into dt is equal to integral g of x to h of x dou f by dou x of x comma t into dx into dt plus derivative of upper limit, that is h dash of x into f of x comma, replace this t by upper limit x comma h of x minus derivative of lower limit g dash of x into f of x comma, replace t by the lower limit g of x. Okay, so this is called Leibniz rule of differentiation under the integral sign. Okay, so basically we are having a function of two variable, namely x and t. Okay, f of x comma t, this is a function of two variable. We need to differentiate this function with respect to t within the limit g of x to h of x. Okay, for this integral we need to find out the derivative with respect to x. So it will become integral g of x to h of x, partial derivative of this f with respect to x plus derivative of upper limit into f of x comma upper limit minus derivative of lower limit f of x comma, this is lower limit. Okay, so once we know this rule, then we can easily solve this problem. Okay, so now let us solve the problem. So here this is the problem. Okay, so given is this one, integral 0 to x 1 minus x square plus t square into phi of t into dt is equal to x square divided by 2. This is the problem, right? Differentiate this one with respect to x, I will get integral 0 to x. So I need to differentiate this function with respect to x. So if I differentiate 1 with respect to x, I will get 0. If I differentiate minus x square, I will get minus 2x. If I differentiate t square with respect to x, I will get 0 into phi of t into dt. Here I am using Leibniz rule plus derivative of the upper limit, it will become 1, and then replace this t by the upper limit. So it will become 1 minus x square plus instead of t I need to replace x into phi of x minus derivative of this 0, it will become 0, and then replace the t by lower limit 0, so it will become 1 minus x square plus 0 into phi of 0. Okay, phi of 0, which is equals to derivative of x square, this is 2x, this 2 is 1 by 2 is constant, so it will become cancel, this plus x square minus x square will get cancelled. So finally I will get integral 0 to x minus 2x into phi of t into dt, minus 2x into phi of t into dt plus phi of x is equal to x, plus phi of x is equal to x. Okay, so from this I can write phi of x is equal to x plus integral 0 to x 2x into phi of t into dt, phi of t into dt. Okay, so call this as equation number 1. Call this as equation number 1. Once again differentiate this equation with respect to x. Once again differentiate this equation with respect to x. So I will get phi dash of x is equal to derivative of x is 1. So here I need to use Leibniz rule. So integral 0 to x. So derivative of this one with respect to x. So it will become 2 into phi of t into dt, 2 into phi of t into dt plus derivative of the upper limit, that is 1, and then here I need to replace t by the upper limit, so 2x into phi of x, and then derivative of the lower limit is 0, its derivative is 0, so that's going to be 0 anyway, so I'll stop here. So from this I'll get 1 plus, I can take this 2 outside, 2 into integral 0 to x, this is phi of t into dt plus this is 2x into phi of x, 2x into phi of x. So this is my phi dash of x. Okay, so call this as equation number 2. Call this as equation number 2. Now look at equation number 1. From equation number 1 I can write phi of x is equal to x. Okay, so this is integration with respect to t, so this 2x may be treated as constant, so I can pull out the 2x from the integral into integral 0 to x phi of t into dt. Okay, phi of t into dt. Here also I am having 2x, here also 2x, so just to pull out this x outside, so from this I will get phi of x is equal to x into 1, x into 1 plus 2 times 1 plus 2 times integral 0 to x phi of t into dt, phi of t into dt. Okay, so call this as equation number 3. Call this as equation number 3. Now use this equation 3 in equation 2. So let us look into equation 2. Equation 2 says that this phi dash of x is equal to 1 plus 2 times of integral 0 to x phi of t into dt. Okay, so instead of this quantity I can replace phi of x, I can replace phi of x. Okay, I can replace phi of x, right, plus 2x into phi of x, plus 2x into phi of x plus 2 times x into phi of x, 2 times x into phi of x. Actually phi of x is equal to x times this one, so this one is nothing but 1 plus 2 into integral 0 to x phi of t into dt is nothing but phi of x divided by x. Okay, right, so it will become here also phi of x, here also phi of x, just to pull out phi of x outside, so it will become 1 by x plus this is 2x, 1 by x plus 2x, and then bring this phi of x into this side, so it will become phi dash of x divided by phi of x is equal to 1 by x plus 2x, 1 by x plus 2x. Now integrate on both sides, so integral phi dash of x divided by phi of x into dx is equal to integral 1 by x plus 2x into dx, 1 by x plus 2x into dx. So it will become, if I integrate this one, I will get log of phi of x, which is equals to, if I integrate 1 by x, I will get log of x. If I integrate 2 into x, I will get x square by 2 plus 1c, I need to add, right. So it will become log of phi of x minus, bring this log x into this side, it will become log x is equal to x square, this 2 will get cancelled, plus one constant c. It can be rewritten as log of phi of x divided by x is equal to x squared plus c. Taking exponential on both sides, I will get phi of x divided by x is equal to e power x square plus c. This can be rewritten as e power x square into e power c. So I will get phi of x divided by x is equal to e power x square into e power c. E power x square into e power c. I will call that e power c as a, where a equals to e power c. Right. So from this I will get phi of x is equal to ax e power x square. Ax e power x square. This is my phi of x. Right. But I need to calculate what is a. I need to calculate what is a. Okay. Now look at this is my phi of x. Okay. Right. And then this is phi dash of x. This is phi dash of x. Phi dash of x is this one. Right. Phi dash of x. This also phi dash of x only. Okay. Phi dash of x. Right. Here I need to calculate the conditions to find out the value of a. I need to calculate some conditions using phi of 0 and then phi dash of 0. I need to calculate some condition, then I have to find out what is a. Okay. So this is phi of x is equal to a into x into e power x square. Let us calculate what is phi dash of x. Okay. So this is equal to, this a is constant. Here I need to use product rule. Keep x as it is, differentiate e power x square. This is e power x square, and then derivative of that x square is 2x. Right. Next, plus keep e power x square as it is, differentiate x, I will get 1. So it will become a into, here e power x square, here also e power x square. Bring out side, it will become 2x square plus 1. This is my phi dash of x. This is my phi dash of x. Okay. Now let us calculate what is a. Okay. What is a. Right. Now look at equation number 1. Look at this equation, integral 0 to x, this one. Here if I substitute x equals to 0, both side I will get 0, so no use, right? So here also if I substitute in this place, in 1 put x equal to 0 in 1. Okay, put x equals to 0, x equals to 0 in first equation. Now let us see the first equation. So this is my first equation. Okay, so phi of 0 is equals to 0 plus this also 0. So phi of 0 equals to 0 I will get. Okay, so if I substitute x equals to 0, I will get phi of 0 equals to 0. Right. Use this condition to calculate a value. If I use x equal to 0 here, I will get left hand side here 0 is equals to a into right hand side also I need to put x equals to 0 into e power 0 square. So here I will get 0 equals to 0. Okay, so using this I can't find the value of a, so I need to use the first derivative also, phi dash of x also. Right. Now let us go for phi dash of x. Right. So where is phi dash of x? Now look at this one in second equation. Second equation is this one. Okay, here you put x is equal to 0, so I will get phi dash of 0 is equal to 1. Here if I substitute x equal to 0, this is 0. Here if I substitute x equals to 0, this is also 0. So I will get phi dash of 0 equal to 1. Okay. So I will get phi dash of 0 is equals to 1. Phi dash of 0 equals to 1. Use this phi dash of 0 equals to 1 here. So that means here I need to put x equals to 0. So here I will get phi dash of x is equal to a into e power x square, a into e power x square into 2x square plus 1. Okay, into 2x square plus 1. Okay, we know phi dash of 0 equals to 1, which implies a into e power 0 into 0 plus 1 equals to 1, which implies I will get a, this is e power 0 1, this is 1, so 1 into 1 1. Okay, so I will get a equals to 1. Okay, a equals to 1. Therefore my phi of x is equal to, already I know phi of x is equal to this quantity ax into e power x square, ax into e power x square, ax into e power x square. Put a equal to 1 here. So I will get phi of x is equals to x into e power x square. So this is the solution to the required problem. Phi of x is equal to x into e power x square, but we need to calculate phi of root 2. So phi of root 2 is equals to root 2 into e power root 2 whole square. So phi of root 2 is equal to, phi of root 2 is equals to root 2 into e square. So the value of, value of phi of root 2 is equals to root 2 into e square. Okay, value of phi of root 2 is root 2 into e power square, e square. Okay friends, if you like this video, please share and subscribe with your friends. Thank you.